In a world of precious memories and heartwarming moments, homes and villages can turn into despair and hopelessness to many across the globe.
It's being called a catastrophe of major proportions.
There has been a huge earthquake, magnitude 7.0, just off the coast of Haiti, the poorest country in the Western Hemisphere.
There's a lot of people in the street everywhere. Some are wounded, badly wounded.
Hospitals in the area are inundated and they are struggling to cope with the number of injured, which has almost doubled to around 6,000 people.
Floods, earthquakes, wildfires, landslides, all of which can ruin thousands of lives in a flash. In 2010, Haiti experienced an earthquake with a moment magnitude of 7, affecting around 3 million people. Furthermore, in 2017, Texas and Louisiana experienced Hurricane Harvey, causing over 100 deaths and inflicting $125 billion in damage. But thankfully, we had rescue teams deployed helping save thousands of lives across these disasters. But it was not without its challenges. These disasters typically destroyed not only houses, buildings, and landscapes, but also roads. The World Bank reported that the road network around Port-au-Prince was limited and the earthquake had caused major damages to around 70 kilometers of main roads. In total, almost 300 kilometers of primary roads were hit, and if you look closer, there's even more. So, what can we do? The Disaster Assist Drone, aka D.A.D, is a project made by 3 UTS students to support emergency services across the world. The project was made to be attached to a drone and then another device for processing and communication. To get started, open D.A.D on your computer. You'll be greeted with this homepage. After clicking the Continue button, you'll be greeted with the necessary information to start using the application. Clicking back, you'll be greeted with our menu. From our menu, you can click the About Us button where you can learn more about the team on this page. To start scanning, we first import the image into the application, after which we can open the scan window and select the image we want to process. Here's a little preview of the image. Once we click Scan, this image goes through a convolutional neural network that performs semantic segmentation on the given image. This extracts the road from the image and is fed into a blockage detection algorithm. This algorithm returns a status that determines if we have detected a blockage on the road. Once we have this image, we can go to our Notify window where we are able to communicate via email to send the necessary information to those who need it. For future improvements, we would love to improve the application by adding other forms of communication, improving the model's accuracy, handling situations like curved roads and sharper turns, and test the application with live drone feed. With our application, we aim to support rescue teams with the help of AI and to better improve the navigation-based problems they run into. This is Team 40 JJI's demo video. Thank you for watching.